floor is yours.
Can you see my screen?
Yes.
Apparently, I should move to my first slide. Let me see. Oh, yeah, I played this one. Oh, wait. Why is Zoom like this way? Sorry. Okay. Is my screen like just my window only visible, like slides only visible, or like it's fine
It's
for you?
yeah, it's good. It's good.
It's good. It's good. Okay, okay, okay. So yeah, today I'm just going to talk about some of the Malayalam projects I am working at the moment. So since I'm working on this, like yeah, like I'm not so active in the LLM space at the moment, even though the advances there are very interesting and anyone wants to work in that space at the moment. So the outline for the talk is like first I will be talking a bit about my mother tongue, Malayalam, and then I will be talking about one project called Malayalam ASR and benchmarking project, which is something I created for a need. I will talk about why I did it and all. Then I will be talking about uh, basically a set of new ASR models which I launched called Begum Whisper model, and Palaka is like something like a demo, which is like Hugging Face Spaces, which is created on top of it. So a bit about myself. I know a lot of people know me already, but yeah, at the moment I work as a team lead and an AI engineer at Sendient.io. In my free time, I like to do open source stuff, and I am a volunteer at one of the Malayalam communities for like working on this Malayalam computing as a field. It's called Swadhantra Malayalam Computing. Yeah. So before getting started to the talk, since this LLMs are so prevalent now, I just wanted to specifically say that nothing in the stock is generated or like, um, if I'm just saying something which is generated by LLM or something like that, I will explicitly say that because people are now saying that they are even creating talks with LLM. And at the end of the day, end of the time, they are going to reveal, okay, the stock was created by LLM. So no, this is a thoughtful project which I have been working for maybe like 2-3 months now space in my free time. Uh, so a bit about my mother tongue, Malayalam. Uh, so it's obviously my mother tongue. It is, I will say, it's still a low resource language, even though it has this much speakers, 38 plus million speaker. But I will say a lot of effort has gone through open source communities in this Malayalam. But like, let's say we don't have any cool stuff which other languages have, like Chinese, Malayalam, or even like the Singlish variant, which I work in. Like a lot of things, there are a lot of variants which are there. So in some languages, I have seen it is well spoken. A lot of people are working in this language. Probably in Malayalam computing as a space, let's say anyone, let's say 10 people have maximum done any contributions at the end of the day. And it's spoken in Kerala, Lakshadweep, Puducherry, which are regions in India specifically. India is blessed with so many languages, I will say, and we have a lot of diaspora of people in abroad as well from Kerala. So that's why I call them as Mallu. So wherever Mallu is living, it is being spoken. So one thing I wanted to talk about Malayalam is like it's an incredibly morphologically complex language. So it is complex compared to other languages like English, Tamil, Hindi, Spanish, and all. And in order to measure a morphological complexity of a particular language, we use metrics such as TTR and MATTR. You can refer to these two papers. These two papers says that like TTR and MATTR are good metrics for identifying the morphology of any language. So just getting into the basics of a few things too. I wanted to explain what is TTR. So in order to explain TTR, I'm just going to go into the basic of a few things. So consider the example like the sentence, to be or not to be is a question. So type is basically the fundamentally speaking, it is the number of tokens, number of unique words you can say in a particular word. and token is like the total number of. There is a lot of tokenization. Maybe I'm not an expert in this, but we can say it's not word, but yeah, like one fundamental unit of a sentence or something like that, we can say. So in this sentence, we can say that, okay, the type count is 7 if we are considering it by like the word, if you are tokenizing it with words. So the type here 2 and B is repeated 2 times. That is why that I am saying the type count is 7, while the token count is 9. So I told you why I explained what is type and token is because to explain the formula of type token ratio. So type token ratio is equal to type count divided by token count. So for this particular sentence, the TTR is equal to 7/9. In order to for this this is a graph which is generated on a study of all the Malayalam corpus text from Wikipedia. So this is the dataset name called SNC corpus of Wikipedia. So what we understood what is tokens and types, and TTGR is basically a graph which is just plotted with as the number of tokens is increasing, types is also increasing. So for not morphologically complex languages, this TTGR will be like after a point, it will flatten out to a straight point. Even after the study was conducted for 8 million words, it hasn't still flattened out or something like that. It is still an exponentially growing curve if you look at the left-hand side of this figure. And TTR, which is a measure, as I said, you can see that TTR for this particular language as the token is going, it is definitely decreasing, but it hasn't like flattened out anywhere. It will even more, there is more chance to decrease even further. So how can I compare with different languages? So this comparison actually was done with languages in European languages as well as some Indian languages. So let's say I'm not saying necessarily European languages, like English is also there, Spanish is spoken, but it is from this corpus, basically European Union Constitution corpus. And in this corpus, how this graph is derived is basically is like, if for you can see in the right hand side, for example, Finnish. So Finnish, the token length according to that study is 0.110 million. So in 0.110 million, in this graph, TTR graph, Finnish comes around, the value of Finnish in Malayalam comes in the top, and this is the value of for the language Finnish as per the study, basically according to the European Union Constitution corpus study. In other languages like Estonian, English, Spanish, and all, you can see the study. So that is why Malayalam is incredibly challenging compared to other languages as such, because morphological complexity is a bit hard. Some things which work in English might not work in Malayalam. That is what linguists say. I'm not sure about that opinion per se, but it's that's what linguists feel about this particular language as such. So you can see that even in Indian languages itself, Tamil is the only close competitor. So in Tamil also, for this 2.98 million language, Tamil and Telugu are where, like, it makes sense also, because Tamil and Telugu are like Dravidian languages. So based on these Dravidian languages, Indian, like Malayalam might have originated. That is a linguistic study about it. But yeah, so this just proves that like Malayalam is an incredibly complex, morphologically complex language. So I just wanted to talk about this in a bit early, because like I wanted to say that, okay, Malayalam is a very hard language to work on, and it is maybe some things which apply in English doesn't necessarily apply in Malayalam per se. So I just there was I want the next topic I want to talk is about this Malayalam ASR benchmarking project. So there was this wonderful event organized by Hugging Face team, which was to fine tune models in various languages. It was held for 2 weeks from 5th December to 19th December. And we got a lot of models in Malayalam also. So these were the list of models which was created in Malayalam. And these models, when evaluated on the leaderboard of Whisper event, gave this much good accuracy. So I will explain why I created this NB Dev project. So why I explained this, why about this Whisper event and the results in this event is because like I found something. I was not convinced by the results which was shared in this Whisper event. So the winning models in this competition was like for Common Voice it was 10L Whisper model, and for Fluence dataset it was this model. But I was really like I was not convinced about this model because achieving 10% word rate in Malayalam is astonishing, I will say. And unfortunately, this was the first time a lot of models was participated. There was no studies on benchmarking, and I will say since it was like a very Malayalam is a morphologically complex language, as I showed in the previous slides. Even achieving 30% WR was a big deal according to me. But the main reason I started this project was because I didn't trust the Hugging Face way of evaluating models. So the Hugging Face way of evaluating models was like days after the training, they usually auto-populated the model with a particular the word rate and the common character rate was calculated based on the test data set of what the author has actually trained on it. So in 10L's model, the fundamental thing which I got disagreed was like he was claiming 11% in common voice, and here in the model card I could see the word rate and the common rate was like word rate was 38. And in his last commit in the README, if you look at it, he just manually edited this. So this word rate, he just changed it from 38.6 to 11.4. And man, I just wanted to call out, and just calling out is not scientifically possible, right? If you don't run all these things on your own. So that is why I actually started this project. Uh, so yeah, till now, if you have any questions, maybe feel free to ask anything. Any doubts or something like that. I just want to pause for some time.
So I have a quick question on is it possible to show us one example or two example of TTR stuff that you talked about, just to like reel it in my head better?
Example in the sense, maybe I can just show you the paper.
Is it possible to show the formula first? I think I missed that slide somehow.
Sure. 1 second. So this is the formula. So TTR is equal to type count divided by token count. And actually, all these things I learned from this paper, actually, this fabulous paper by Kavya Manohar called Quantitative Analysis of Morphological Complexity of Malayalam Language. But yeah, if you are curious about the formula, so TTR is equal to type count divided by token count.
Can I ask again what type was?
So type was basically in a word, the number of unique characters, you can say. Simply speaking, number of unique characters.
So if you're using a word tokenization strategy, subword tokenizer, like a BPE one, right? You're going to break down some words into subwords, and some will be the same. That will be your token count. How does this relate to type? Is it the original word, the original unique number of words, or is it something else? I'm trying to think of it in terms of word tokenizers, but then when I think of character tokenizers, I don't know if this works for that. So I'm just curious, if we stick to the word tokenization.
Character, yeah, like if we stick, I think this was done, the study was done in word tokenizer, it seems. So in this word, probably this was done in word tokenizer itself, because I don't think the author, I had spoken to the author previously, but then I think this is what so maybe I can check whether it was done in subword tokenizer.
I'm just trying to understand type by understanding how they did the tokenization. So that's where my question comes from. That's all.
Got
Thank you.
it, got it. Yeah, I think here the type is like the unique words, while since it is a word tokenization approach, and the token is like the total number of words.
Okay.
But this is on a sentence level, right? So how do you actually compute it on the language level, particularly that graph of you which you presented, like they say, like first 10,000 words, let's say, then 100,000 words. That means most frequent words in the language.
I think so, because after a point, right? For example, like the unique type will be like the unique word. I'm just assuming in the study, but if it is, if I'm going with this word tokenizer is the assumption, if it is being used, then like type will be the unique number of unique words, and token will be like, okay, in this whole corpus of Wikipedia text, as the text was being scaled to like millions of ranges, this was the graph it took time.
So is it fair to say that this is the number of merges that correlates with the number of merges you have to make, or the size of the merges file?
I'm not sure about that. Even I'm also not an expert, but I was trying to understand this paper to basically this all this the first section is from this wonderful paper by quantitative analysis by my friend Kavya Manohar. So she has done some incredible work. She had did it as part of her PhD work. So, and it was published in some paper also. But I don't know. Maybe I can. If you have any questions, maybe I can ask her. Is it fine?
Because this
Awesome.
plateauing is very funny, right? It's like on the previous slide. It's not happening there, and you just see that. Okay, if you have, I presume the x-axis is the number of actual words, right? And then what you get the number of times, like pretty much comparable. It's also in millions, right?
Yes,
and that's
yeah.
it's just I kind of don't get this part, right? So why, like, you add new words to the vocabulary, let's say, and those results in new types. This is what it means. So you always kind of you keep increasing the vocabulary size, but then you also proportionally increase the types, right? That means that the tokenizer somehow is not able to reuse the previous tokens, which were already tokenized from previous words.
Even I'm also not sure about this. Maybe I'm also not the expert in NLP, to be honest.
No problem.
Can I suggest something?
Yes.
Maybe we can have this discussion after the presentation, so you feel less, stressed on the spot. Because
it's fine. It's fine. Yeah,
so,
it is fine.
So we can continue, and then maybe once it's done, yeah, Malayalam is complicated.
It is complicated.
Yeah. I think it will be interesting if you can show us with examples later how it looks like and how you break it down. But we can continue for now. Yeah.
Yeah. Okay. Yeah. So I think I was right. So yeah, in order to basically, I wanted to have a framework to test this. So that is why I created this Malayalam ASR benchmarking as a new GitHub project, which is based on NVDev. So that like I want to calculate the word error rate. So I did a few results, and like I just benchmarked first on common voice. And this is something, if you are like working in low resource languages, this person is, as I said, she's a good friend of mine, but then she has been working in the speech field for 5 years. And she has been saying, man, there has never been a benchmark for comparing Malayalam ASR models. So it is incredibly nice because there is a lot of quick wins, I will say, if you are working in low resource languages. So yeah, let me just talk about how I benchmark this model. So benchmarking itself was a very interesting part for me. So I started with 6 fine-tuned models in like which was participating in the Whisper event. And I just compared it. I also used the 6 models, release model versions, which was released by the OpenAI also. So these were the 6 model weights, which was created by a lot of others. And I just used few models only because for my study, in order to make it easy, I choose this number 6. There were some models which were difficult to run, which participated in Whisper event, so that I just avoided. So if you look in common voice dataset, which is one dataset which is available in Malayalam, if you see compared to OpenAI's models, you can see that our models in fine-tuned models in Malayalam gave us very good results. So one thing I can this direction prompted us, like in the OpenAI's Whisper paper, there was this wonderful question like, will fine-tuning improve the results? Obviously, it improved their results, and we got phenomenal results on fine-tuning on top of Whisper. And you can see this is the graph on Common Voice dataset. So in this Common Voice dataset, from 150% or even the best model is 100%, and the 10L model got almost 11.56%. So this is the word error rate for the Common Voice dataset. And for the character error rate, which is another metric which is very commonly used in Common Voice dataset, it is, you can see that it also decreased from 93% character error rate to 5%. Please note that in it is just word error rate, and it is just like error rate, similar to accuracy. So it is most of the time we can consider it is 100 minus error rate is can be considered as accuracy for most of the models in ASR world. And another dataset I used called Malayalam Speech Corpus, and in this dataset also we got phenomenal results. In this dataset, okay, the OpenAI models also had 100% word error rate, while Tender's model went as small as like 2% word error rate, and the character error rate was 1%. So definitely this, I did a same talk on, like I did a talk on Position Conference 2023 this year in Singapore, basically telling that fine-tuning models in Whisper can give us fabulous results based on our experience in Malayalam. So if you try it in your language also, you may be able to get wonderful results. So this Malayalam ASR benchmarking project as a whole, I will say the end goal might be somewhat similar to like the Open LLM goal. So this is something which I'm like trying to work forward it, like to it. Like now Open LLM leaderboard is there, like we can like benchmark the various models in various datasets. So probably my idea is also something similar to that, like whatever new models which come in the open source world, obviously we can't do it in the closed source world. Any open source models, if it is coming, like I know Kavya have been working on Kaldi models. There is a lot of Whisper models I have already benchmarked, but now Meta also last week launched some models. So I want to test all these things out and see what is the performance in Malayalam. So this is some kind of direction which I'm thinking to go next in this project. Now about the Vegam Whisper medium models. So Vegam Whisper medium models, actually it was inspired by this model called Faster Whisper. So Faster Whisper is one interesting model, I will say, probably came back from 2-3 months back. And this open source project, it just was a re-implementation of OpenAI's Whisper using C Translate 2, which is a model which is for running these ML models in a fast inference engine on top of C++. It seems I'm not sure, 100% sure, and all these information are actually from the GitHub repository itself. So of the Faster Whisper, and it claims to be 4 times faster than the OpenAI Whisper model weight, and even the CPU and the GPU memory is more efficient compared to the original Whisper weight, and there is not much accuracy trade-off as well. So using the C Translate 2, which is this wonderful tool, it had this utility for Whisper-based microservices. So if you just look at this link, you will see that like it has this utility for all the some of the transformers model, not all the transformer models, but now Whisper is also added. And basically you just need a CLI command like CT2 transformers converter -- model, and just give the Hugging Face repository, that is like the OpenAI Whisper Tiny, and just store it in your repository in your output directory as a whole. So then you will get the output for C Translate 2. And then, yeah, so based on this, I just took Tennel's Whisper Media model, and then I released two open source models, Begum Whisper Medium ML and model which is only focused on FP16 models. The other model can be run in FP16, Indate, few more quantization techniques. All the quantization techniques supported by faster Whisper supported in this Begum Whisper Medium ML model. That is the case of this, and Pallak is just a Malayalam speech to text demo, like I will say, like leveraging the model weights of Dragon Vista Medium ML. So I created a Hugging Face spaces, and now I'm working on a GPU based microservice as well. And if you are interested in this, you can just check the link here, and yeah, this is how the Hugging Face spaces looks like. So if you just enter an audio and corresponding to that, you will get the output. So yeah, I think that's all, and a big thank to all these people, wonderful people who helped me with this project. Obviously OpenAI, Stephen Play, to all the people who helped me. I'm thankful to that. So yeah, I think that's all from my side. I'm open to the questions now.